Section 7.5% of change. A percent of change indicates how much a quantity increases or decreases with respect to the original amount. And I've already filled in a lot of these words. You can go ahead and copy them in. If the new amount is greater than the original amount, the percent of change is called a percent of increase. If the new amount is less than the original amount, the percent of change is called a percent of decrease. That's a lot of words, but really what we're thinking here is back in like the 1950s, for example, you could buy a house for like $8,000. Now, common price for a house is $200,000. Things have gone up. So that's a percent of increase. The original amount was smaller than the new amount. If you watch Greatest Loser, where they have the people on the TV show to see who can lose the most weight, that's a percent of decrease. They start with a certain weight, and by the end of the show, it's whoever has the greatest percentage lost, percent of decrease, that's who the winner is. So that's what that is. You start with a high amount and you go down. Now, if we're looking, regardless of increase or decrease, if they're just changing, either for the positive or negative, this is what we're going to do. The formula is going to be P% is equal to, you're going to find the difference of the two amounts. Okay, so you can always take the larger one minus the smaller one, doesn't matter if it's first or second, and you're going to divide that by the original amount. This will give you a decimal, so once you're done with all of that, multiply it by 100. So let's try some, because like always, once you actually do it, the formula makes a lot more sense. In example 1, the International Balloon Fiesta takes place every year in Albuquerque, New Mexico. In 1999, 903 hot air balloons participated. In 2000, 1,019 balloons participated. By about what percent did the number of balloons increase from 1999 to 2000? So we know that first there was 903 hot air balloons. Then a year later there was 1,019 hot air balloons. So they want to know by what percentage did these balloons increase? What percentage did their people go up by? So we want a difference of the two amounts. So I'm going to subtract 1,019 minus 903, and I'm going to divide that by the original. So the original is what we started with, which is 903. So on my calculator, 1,019 minus 903 is 116. Divide that by 903, and I am going to get a decimal, which is 0.128, and it goes on and on and on. I'm just going to round it to that, turn it into a percentage. So it increased by 12.8%. And then below that, it's written here, why might this be important? Because it seems completely irrelevant or unnecessary. But if you were somebody working for this balloon fiesta, maybe you would need to figure out how many extra people you need to plan food for or plan crafts for, or whatever it is that you're setting up shelter for, things like that. So you would have to increase those also by 12.8%, or use that as a rule of thumb. Okay, in example 2, they're just giving us two numbers. One's labeled original, one's labeled new. So the first step, find the difference of the two, so 25 minus 20. Second, in the denominator, you're going to divide by whatever the original was. So they're telling us the original is 20, so there we have it. 25 minus 20 is 5 over 20, simplifies to 1/4, which is the same as 25%. In this, it was 20, it went up to 25, so that's a percent of increase. If we try these two down here, original and new, first I just subtract them, divide by the original. When I do that, my decimal is 0.26, so I turn it into a percentage. 26% increase. And I know it's an increase because originally it was 150, it ended at 189, which is higher. So it went up to an increase. Part B, I'm going to subtract the two, 143 minus 55, and then I'm going to divide it by the original. And the original is 55. So I get 88 over 55, which is 1.6. or 160% increase. And some people said, well, how can it be over 100%? And that's because it did more than double. And so that's why it's over 100%. All right, let's look at the next side. Example 3, find the percent of decrease. So the only difference here is that if we notice the numbers, they're going down. It starts at 512, the original amount, and it goes down to 320, so it's a percent of decrease. So same as before, though, I'm going to subtract the two numbers and divide by whatever the first number is they give me, or the original, 512. So 512 minus 320 is 192. Oops, I wrote the wrong number there. 512. And whenever I get that as a decimal, I can turn it into a percentage. So this is 37.5% decrease. Examples A and B in the U-try. We're going to subtract the two of them. 20 minus 15, divide by the original, which they note is 20. So I'm going to get 5 over 20. 5 over 20 is 1/4. And again, I have on this one, like we had on the other, 25%, but it's a decrease here because from the original to the new one, it went down. Part B, I subtract the two of them and divide by the original. The original is 75, so I get 40 over 75, which is 0.53 repeating. As we did on the other side, I said, other lesson, I recommend you write the repeating decimals out so that we can see that's a 53.3 repeating percent decrease because the values go down from 75 down to 35. Okay.